Hello, this is Mr. Hupp, and let's talk about acceleration. If you look at your formula chart and you see mechanics, you'll see acceleration, and they give you these two formulas here, this one and this one. These are both formulas that they're the same formula. This is an acceleration formula. Traditionally, this formula is shown like this. Acceleration is a change in velocity divided by a change in time. If you go over here and look at this one some more, you'll see that it's the change in velocity, the final minus the initial. Let's write that down. Delta equals final minus initial. So we have the final minus the initial divided by time. We rearrange that to solve for the final velocity here, and that is the final velocity is equal to the initial velocity plus acceleration times time, or the product of those two. Also, you'll notice in some textbooks, instead of VI and VF, they will use V0 and V1 for initial and final velocity. It is important to keep in mind that X and Y are independent motions when we talk about projectile motion. So don't confuse the two. If you know something going on in X, you don't know what's happening in Y, and vice versa. So don't use one to talk about the other. X is not Y. Okay, let's talk about units. The units for acceleration are meters per second squared, and if you think about that, that makes sense because it's the change in velocity every second. So it's meters per second, which is meters per second squared. The initial and final velocities are both measured in meters per second, and time is going to be measured in seconds. Gravity is also an acceleration, and normally we use the lowercase g to represent acceleration due to gravity. It's usually represented with a negative 9.81 meters per second squared because it is normally going down. It has a direction. It's a vector quantity. So you need to recognize that A might be gravity. Let's look at this problem. We have a person pushing a boulder off a cliff. It's going to fall. It starts at 0 meters per second. This is a key thing to be aware of. You can have 0 as a starting value or an ending value, okay? So things that start at rest or come to a stop, those are velocities you need to consider. It's going to be accelerated by gravity at minus 9.81 meters per second squared. It's going to fall for 3 seconds. We want to know what the final velocity is. So we go over here and we use our final velocity formula. VF is equal to VI plus A times T. And we know that VI is 0, so we can cancel that. So it's actually VF is A times T or G times T. So we plug in our numbers, 9.81 times 3, and we get a final velocity of minus 29.43 meters per second. One of the things you can do is you can, for quick estimations, you can say gravity is roughly equal to 10 meters per second squared if you're just doing calculations in your head. Let's consider another problem. So here we have this car. It's driving along, and there's a little kitty in the road. They throw on the brakes to come to a stop. It takes them 2 seconds to come to a stop. What's the acceleration of the car as it stops? So we use the acceleration formula where VF minus VI divided by T gives us the acceleration. We're starting at 0 meters per second, and we are starting at 12 meters per second. So 0 minus 12, the time is 2 seconds. So negative 12 divided by 2 is negative 6 meters per second squared. When it's negative, that means you're slowing down, not speeding up. So you can have an acceleration that's negative. That means you're slowing down. And that's enough on this one.